We're going to talk about IP addressing today. We don't have slides. We wanted to make this more of a conversation. I will warn you that I'm going to ask you to raise your hands a lot, and I'm going to ask you to put your hands down a lot. So if you need to limber up a little bit beforehand, get yourself loose. The other thing is I might ask some questions during the conversation. So if you're really eager to ask a question, just hustle up to one of the mics. I think we're only going to have time for maybe one question during those times, and we'll try and save a little bit of time for questions at the end. But who knows if we'll actually have that time. So, and please don't tackle each other if you know. Okay, so quick introductions. My name is Jeremy Johnson. I'm a product manager on the cloud networking team. And with me today, I've got Patrick Ancelotti from Vimeo. And Patrick runs both security and systems at Vimeo. He's the VP of Systems and Security. And to his left, we've got Kyle Mosquero. He's the director of DevOps and Security for Bitly. And pretty much it's very similar roles, runs all of systems and security at Vimeo, or pardon me, at Bitly. And to his left, one of my colleagues, Olivia Voltran. He is a product manager in the cloud networking team as well. And so with not much further ado, I'm going to get started. So when we think about IP addressing in the cloud, one of the things that strikes me often, because this is my area of focus, is that the last non-elastic resource in cloud is the IP address. Usually when you're out of IP addresses, you're out of IP addresses, and it can cause a real problem. And so this is why we thought this would be a useful conversation today, because I think we all struggle with some issues with IP addresses. We kind of break this down into two categories, sort of public IP addresses, so IP addresses that have access to the internet, and private IP addresses, generally our RFC 1918 space. So we're going to start by talking about how we think about private address space. And I talked to Patrick quite a bit about this, and Patrick's got a pretty unique viewpoint on the differences between private and public IP addresses, or the lack thereof. So I'll just hand it over to Patrick.
Can everyone hear me right? I can't hear me, so I'm assuming you can hear me. One of the things that's a little different about the way we treat IP addressing is to us functionally, there's no difference between a private and a public address. Like public addresses face the internet, there's a technological difference. But we don't inherently trust any network. So for us, it's about explicit instead of implicit security. We go out of our way to make sure that even if something is talking over the internet, there's encryption, there is explicit firewall rules that allow this thing to talk to this thing, instead of saying this network that we trust as secure is able to talk to us. And so we spend a lot of time thinking about, if any of you've watched any of the Beyond Corp talks, think about it like a Beyond Corp style behavior for network security in the cloud. Google behaves this way internally too. There's no Google service that talks to another Google service, even over a Google network, that is unencrypted and isn't explicitly allowed to do so. Does that go? Did I get that right?
Yeah, and I think Kyle has a slightly different viewpoint on this.
Yeah, our environment's a little less complicated than the Vimeo environment, so we take a much more simple approach to running a single VPC. We use our IP address range in the private space in full RFC, and we have to map and balance that across our on-prem solutions across Direct Interconnect. And our public IP address concerns only revolve around a single Class C. That is the root of all of the problems that we face at Bitly from a public perspective, and we'll get into more of that later, but we keep it on an implicit trust within our VPC. So if you're in our VPC, you have a trust with some obvious basic firewall rules to talk to just about anything else. So it simplifies our CI/CD pipeline and other things.
Yeah, so it seems that we have really two different models here. I mean, so on Vimeo side, there's no trust inside the VPC, right? You have an explicit security policy between each VM inside the policy. And in Bitly side, I mean, you have the limit of trust, which is the VPC, and inside this limit of trust, I mean, everything can connect everything, right?
Yes, for some limited aspects, but yeah, everything can connect everything. We put a lot of our security focus at the border, and then inside we realize that if you've already broken in the door there, like you're going to get around for now.
Yeah. So when we designed those solutions for Google Cloud, in our mind, the VPC is a limit of trust, and we designed two models for team securities. So there's shared VPC that we introduced last year. In shared VPC, if you have multiple teams, all those teams are going to be in one VPC. You have a centralized team doing the management, the security management for all those teams. So centralized team of network admin doing the management for all those teams. But each team can be in different projects inside this VPC and so have different IAM rules or different billing, right? The other model is one VPC per team. When you have one VPC per team, then each team will have different network admin and different IAM, different billing, but different security rules. And to connect them, you can use VPC peering that we introduced last year as well. You can use a VPN, and you can use VM multinic. You can also have multinic and a VM. I think you're using VPC peering, right?
Yeah, we're using VPC peering. We enabled it pretty early on for some. We were doing I'm on my third cloud migration of the last 18 months, so I've got a lot of gray hair now. I'm a lot sadder. But during one of the migrations, we take the stance that each functional unit should have both a development project and a production project. And one of the production projects needed to speak private. We weren't able to add encryption to the protocol. So we opted to use VPC peering because it at least gave us some, it moved us towards the aspiration of everything needing to be encrypted. So with VPC peering, there were a lot of advantages, but there were some hiccups that we ended up bumping into, which is one of the, we built a tool around solving some of these problems.
Yeah, so this is where I'd like to ask the audience some questions. So how many folks in the audience, we've talked about sort of the idea of implicit trust versus explicit trust. The implicit trust model would really leverage that shared VPC and host project, whereas the explicit trust model might prefer to use separate VPCs and VPC peering or the multi-NIC approach. So how many folks in here use more of the shared VPC model? Awesome. It looks like maybe about slightly less than half of the room. And how many folks use shared or use a model where you're using explicit trust? It's kind of not quite the rest. So I suspect
you guys are better.
Yeah, there were a couple of both. There are some that didn't raise your hands. So I suspect those that didn't raise their hands probably are using, maybe smaller deployments with a single project. All right, let's move on. So one of the questions we also ask ourselves while we're designing these systems is kind of why bother with IP addresses at all? This is, obviously we need IP addresses on the host, but to solve some of that elasticity problem and some of the programmability problems that we have, especially when you have explicit rule sets to manage, it might make sense to provide an abstraction, like a label, a tag, something like that, as opposed to just an IP address. So we do support some of these concepts in our cloud, and so I'm going to hand it over to the panel, and we're going to talk about abstractions now.
I'll start. So one of the hardest documents that we've ever tried to write, early in our first cloud migration, we have a data center, and the data center has static IP addressing, and we've got as Jeremy calls it, the #1 IP management tool in the world, Google Sheets, and we're updating the sheet, and we start doing the same in GKE because not GKE, in GCP because, well, like machines are going to be stateful. We're just doing a lift and shift, and then we're going to reorganize. And after a couple of weeks, we start to notice that no one's updating the IP address management tool, and things are starting to appear in the environment, but nothing's overlapping because the IP addresses it's an all enforced. And then we started to deploy GKE, and everything became completely trashed. So GKE is wonderful, but if any of you have ever deployed it, every container gets an IP. There is no way you're going to build any sort of human-involved IP address management with that in mind. And a lot of the time we spent doing that was more, we kept trying to lift concepts from our on-prem data centers and from our offices and on-prem locations into the cloud and being like, this should just sort of work. And like, we all know better. Like, we should have known better. But slowly but surely we realized that like IP addressing is not actually that important to us. It seems to only come up for us when we want to overlap with something that is in a physical space. And we've worked around it in other ways.
My end goal is to never care about IP addresses again. We're actively involved in a lift and shift of a lot of our infrastructure into GCP right now, and so we have to use them. We have to use IP addresses for our firewall rules, for our ACLs, for the direct interconnects that we have between data centers and GCP. That's a requirement because we're not going to get to go anywhere else, and we're not going to get any security unless we do that. But as we're putting products inside of GCP, tags are pretty much becoming the best thing under the sun for us. It's logical, it's easy, it scales really well. You don't have to touch it after a time. And I'm going to throw a small softball question over to you, which is, we had a lot of trouble figuring this out at the beginning. Can you explain the functional difference between tags, labels, and maybe service accounts?
Yeah, I think
This is important. This is
something
really
that
important.
Olivier really focuses
take
on.
this
Let's
one.
have Olivier.
So there's a label, tags, and service accounts, right, that are used to, to group IP address or resources together. Labels are only used for billing, so they're not used at all for security or networking. So label only billing. So for security and grouping mechanism for networking, we have tags and service accounts. So the big difference between the two, so service accounts is a bit more recent than tags. I think tags was released like 2-3 years ago, I guess, something like this, and service account last year. The big difference is if for tags, you can have multiple tags per VM, right? For service accounts, you can only have one service account per VM. So that's one limit. The advantage of service account, though, is seen as a bit more secure because service accounts, you can design IAM rules to decide who can add this service account to this VM, right? So it can be a bit more granular into who can change those service accounts rule for each VM. So that's a big difference. But they can be used, they are used the same way. They are used to group VM together for firewall rules and stuff like this. Yeah. So just one point on getting rid of IP addresses. So I have a bit of an issue with that. So I'm hearing a lot from customers that, let's get rid of IP address and let's use label, and I want to connect red with blue, but blue cannot be connected with green. Let's get rid of IP addresses and use color or label for all of this. There's two issues I see with that, and I would love to get your point of view on that. The first one is there's always a limit of trust somewhere, right? So if you manage everything, then it's very easy to color your source with those labels or with those tags and so on. But if you receive routes from somebody else, right, you cannot trust those labels, right? For example, if you receive BGP routes or if you're doing peering and you're receiving some traffic from this other network, you cannot trust it, right? So there's need to be a way to a policy to map those labels to those IP address. So I don't see those IP addresses disappearing, even if it would be a nice goal. And then that could be perhaps an implementation issue. So that's something we could perhaps find a workaround for that. But there's a scaling issue in the sense that if you have one label per VM and you have a firewall rule for them, basically you have like one firewall. If you have 10 VM, you have 10 firewall rule, right? In the implementation. Because it's really /32, right? While IP addresses, you can aggregate them, right? You can do /24, /20, and so with one rule, like map like 200 VM or something like this. So there's scaling advantage also in IP addresses.
Yeah. You go first.
So we need subnet masks for tags. Okay.
Yeah.
Coming soon from Google. Okay.
Right.
Or perhaps for smaller management, for smaller customer, it might work better than for a larger deployment, for example. So we need to find a way to use the flexibility of tags and still have the scaling.
Yeah, something we use internally at Google that is also useful is sometimes we identify things. You think about what you use IP addresses for. You use them to apply policy. Use them to secure communications between two entities. But you also use them for identification. That's primarily why they're used in GKE, for example. And one of the things we do inside of Google is we actually use a tuple that's the IP address and a process ID. And something that we would probably extend to, this kind of pattern also works probably well with the lower order bits on v6. We'll talk about that in a minute. Before we get into this, really quick, just a poll of the crowd again, so loosen up. How many of you folks are using tags in your deployments today? Oh, that's great. That's almost everybody. How many folks have used service accounts in your deployments? Also a good number. That's almost all the room. That's great. So, by the way, I'd encourage you, if we're talking about something that you really want to talk about, walk up to the mic and ask a question. I think we're gonna move on into so Patrick mentioned something that's near and dear to my heart, which is the IP address management. Yeah, this is a challenge that we all have, and I think that IP address managers were not built for clouds. Almost saying IP, anything about IP wasn't really built for clouds, right? We have overlapping namespaces. We have poorly coordinated deployments where, developer A isn't talking to developer B, and they both end up on subnet A. This happens all the time. So how do we avoid these kinds of things? We really actually need a good IP address management system that's really built for cloud deployments. And so we have to move beyond spreadsheets, right? So before we talk to the panel about this, how many of the folks in the crowd are using spreadsheets to manage IP addresses? Okay, the honest ones that raise their hands is about half the room. And how many folks in the room actually have a commercial off-the-shelf or home-built IPAM solution? Okay, a little less than half. So again, there's some people who just aren't managing IP addresses.
And Jeremy, just in those folks that say that they are using IPAM, who is using those IPAM to manage cloud resources?
Only a handful. Yeah.
Our subnets are in IPAM, but we don't manage it.
Yeah, makes sense.
Yeah, so subnets are in IPAM, but not managing individual IP addresses.
It depends on the environment because if IPs are ephemeral, it almost needs to be.
This is exactly the point. So we're talking about this idea that IP addresses in cloud are oftentimes ephemeral, especially as we move towards microservices, right? So what kind of human-driven IPAM, kind of helps with that? So I'm going to kick it to the panel and get some thoughts on this.
So I probably have to start with some organizational stuff to explain how I got to where I am. So Vimeo practices engineering autonomy. So if a team would like to progress faster than the rest of the organization can, they have the freedom to do so. Sometimes that results in some stuff that wasn't planned for, but isn't the worst stuff, but also isn't the greatest stuff. So we, in our biggest production project, we use auto IP addressing. Is everyone familiar with when you create a network, it gives you a bunch of IPs and they overlap everywhere all the time. And once production services are living on a network, that's where they will stay until you die. So in a lot of cases, we've ended up using auto subnetting, not because we planned it that way, because truthfully, we didn't, but because the progress to the cloud happened before we had infrastructure folk involved earlier on, which is a great thing for the company, and we still wholeheartedly encourage engineers to move quickly. But it's something that's really hard for us to undo. And at least I, for one, would love to have something where I could, at least organizationally or somewhere within GCP, define available ranges and allow networks to be created out of those and reserve them, sort of like an IPAM. But I don't have any physical infrastructure anymore, so it's easy for me to say that without having to worry about the on-prem stuff anymore.
Let me ask one question of the crowd really quick. Is the distinction between auto mode and custom mode subnets clear to everyone? Okay, I see a few shaking yes, a few no. So I'll just explain, at a high level really quickly. When you create a subnet in a VPC, you can have a VPC in auto mode, in which case every region will have its own subnets just automatically allocated for you. The custom mode allows you to choose your own range and set your own subnet mask. So the thing that's interesting about this is if you've got developer autonomy and the ability to build a VPC on your own, you might really like that auto mode because you don't really want to think about IP addresses when you build out your project. On the other hand, if you do have an IP address policy, right, and you do have concerns about talking to other organizations with your project, et cetera, then you need that custom mode. The distinction is even more important when you realize that in order to convert from auto mode to custom mode, you have to drain the auto mode VPC, which means you kind of got to start over. So it's one of those choices that you make that has lasting implications, right? And I think that's what Patrick's getting at. They did a lot with auto mode, and they don't want to go backwards, right? We're always moving forward. So anyway.
So naturally, we started with auto mode and then realized really quickly that it, of course, overlapped with our private IP address scheme that we had in our data center. So we had to start back over. And we also heard some great horror stories from our product team and our TAMs about why we shouldn't use auto mode. So that was always fun to hear other people's pain. But as it comes to our address management, we're using spreadsheets. We're using Google Sheets to track our IPs right now. And our hope is that as we move forward, we're not going to need to do that anymore. And Jeremy said IP addresses weren't really designed for the cloud, and I agree with that. And I think that if you're spinning up thousands of containers every day, every hour, there's no human-readable format that's going to be useful to you, right? The only thing you can trust at that point is what your API tells you is correct this microsecond or millisecond. And because of that, organizations and process and policy has to change about how you're choosing to manage those. And maybe ephemeral is not the right word for how I think IP address management has to happen in the future, but it's something near there. It's the IP address becomes this arbitrary thing that just exists in the code for you and controls certain access to certain thing. And ideally, in a cloud environment, that's programmatically done through tags or some other thing where you can come in and set that defaultly.
Yeah. So one thing that we think is a typical IPAM don't work in cloud. So one reason for that is one feature of an IPAM is the mapping of IP address to DNS, to the DNS address, right? And that is done automatically on GCP. So in that sense, we are doing already a big feature from a traditional IPAM, right? So an IPAM for cloud needs to be very different from an IPAM that could be used on-prem. One quick question for Patrick. So I know that you have a tool to manage your security, right? Do you mind discussing a bit about that and why you had to build the tool in the first place?
Sure. I think.
Oh, that's a question?
Oh,
sorry.
Yeah.
Sorry.
Hi. So you're talking a lot about IPAM in terms of managing individual addresses, right? And this gentleman is talking about how he's actually managing it like the subnet level. So one of the things we're getting really heavy in on is using Kubernetes on shared VPC, which means it has IP aliasing, which means I've got 3 subnets per Kubernetes cluster, plus Google, and we're doing private clusters. So then Google picks a 4th range that they're going to peer in. And then if you're on internal IP space, things like Cloud SQL, it seems like there's a lot of peering. So I don't know if it's more of a comment than a question. And it feels like they're still on IP space because my spreadsheet's pretty big, but it's subnets.
Yeah.
And it's really trying to manage assignment because I'll have 4 to 5 subnets just for a Kubernetes cluster. And keeping track. And some of these are like peered space that can't overlap. And Google reserves like some of the 172 space for its peering that's magic. A tool, I think, would still help to manage that level of stuff because that itself is starting to feel like it's going to get overwhelming. Right.
I think this is something that I was going to bring up. The use of IP addresses in Kubernetes is it's an area that we get a lot of concern about, right? And I would recommend that anyone who's concerned with that topic should go. There's a talk over at the Palace Hotel today at 11:40, I believe. That's Enterprise Kubernetes. I'd highly encourage you to go watch that. Or if you can't make it over there, just find the YouTube video after the conference. because they're gonna be talking about some things. We're introducing some concepts like custom mode Kubernetes IP addressing, and so to a certain extent, when you build your GKE cluster, you're getting the auto mode treatment, right? And we recognize that that's not exactly, we did custom mode in VPC for a reason. We felt like, okay, well, it's probably about time we did custom mode for GKE as well. And so there's going to be some more information about that. But at a higher level, some of the things that happens every pod gets its own /24, right? We found that that nominal number of pods per machine or per node is usually around 8. And so a /24 is a little excessive. So we want to be able to more or less right size that. So we're adding some features for that, and there's a lot more information about that today at that Enterprise Kubernetes. Yeah. So
I guess that's been one of our biggest challenges. We have a development team that went in with GKE, and we kind of told them, well, okay, we'll let you do this. And then all of a sudden they decide to do 10.0.0.0/14, which is pretty much the rest of our enterprise. And kind of had us do some trickery with VPN to not propagate that stuff down, to kind of give some segmentation. But I know, like, for example, there's IP masquerading, but that kind of goes almost completely against everything that Kubernetes does, because I remember talking to them, I was like, yeah, why don't you NAT? And they were like, we don't want a NAT. So I started kicking around the ideas. I know this is the big no-no for all the people in here who are doing IP, but IPv6. Because
we're gonna hold that topic to the end.
Okay.
So I have a lot to say about that.
Okay.
Hopefully a lot to say about that. But yeah, I do think IPv6 is important. Let's hear about Patrick's tool real quick.
So during all of when we were converting from Kyle to where we are now, I'm a little shorter, but one of the things that we found, there were a lot of times we wanted to talk to things outside, and there wasn't a great way to control the firewall rule management. So, like, we're big Fastly customers, being able to take Fastly's ranges and say extending our explicit security behaviors to the edge, we want only these N ranges to talk to these 5 origin servers, or this group of origin servers, or this GKE cluster, and we extended it further. We wanted to be able to say when a GKE cluster comes up, it can speak to this database server. And so we built, for all intents and purposes, a firewall rule convergence tool. So it watches all of the assorted infrastructures, our AWS stuff, our GCP stuff, our Fastly stuff, and it has a config file that converges into API-driven firewall rules. So it'll go and say, oh, I see a new instance. Within a minute, it catches the event, it creates the firewall rule, updates all of the ones it needs to, and so we're able to dynamically generate firewall rule maps. So when we talk about explicit security, if I was doing it all by hand, like, it just wouldn't happen. Engineers are lazy. That's why we're engineers. And so we call it Border Guard. We're going to be open sourcing it at some point. But it allows us to care even less about IP addressing, because we really care about entity security. And so some of the things we could easily do with service accounts, we could inter-application or inter-virtual machine communication. But as soon as we extend past what is a VPC boundary or past what is a project boundary, those tend to stop being viable for us.
Yeah, I think so. Just to kind of summarize this topic, I think with cloud, and when we start talking about infrastructure as code, right? We have to be able to manage IP addresses more based on intent, right, than on strict policy that is enforced by humans, right? And so what Patrick's team has done is they've been building this tool for a while to automate all that. And as he said, you're not going to be able to get to this level of explicit trust without an infrastructure as code model. There's just no way that you're going to get there. So we're also, things might look bad to a certain extent, but also given the fact that we're opening APIs to to be able to automate our infrastructure nowadays, we are actually getting to a place where we can do more, better, faster, and stay more on top of what's going on. I think my answer to Olivier's objection about the cloud IPAM not dealing with, maybe DNS or the DHCP stuff that you may not have as much control over in cloud is that I actually still, I look at IP address management less as a product and more as a set of features or a set of functions. And those are things that roll out as APIs over time. And so, and those APIs will facilitate the kind of tools that Patrick's putting together. If you are on the explicit security model with IP address management, I would encourage you to look at their tool, watch this space. I think it's called Border Guard is the tool that they're building, and it'll be open source at some point, correct?
Yep. It also has a really neat feature. Again, engineering autonomy. One of my engineers got a little annoyed with finding random firewall rules popping up, because explicit security makes people's lives a little more difficult. And so now it has nuke mode. It will go through all the rules and be like, I don't know about these, deleted, which helps.
Okay, we're going to shift gears one more time and talk about public IP addresses. It's not as controversial a topic in a lot of cases, because for enterprises, the public IP address is primarily used to go fetch updates to your operating system, security rules or updates, and maybe package management. But for companies like Bitly, for companies like Vimeo, where you have a strong public-facing part of your business, the public IP address becomes also very important. So I'm sure Kyle has some thoughts on this.
So Bitly's technology relies upon DNS, which is arguably the most advanced protocol that's ever been made on the internet. So we are basically held hostage by the IP addresses that we've been using since 2008. We have one class C. We point every customer domain. We have thousands of customers, tens of thousands of customer domains, all pointed to 2 IP addresses. So we are stuck in colo providers and much more antiquated systems where they will still allow us to bring those IP addresses within their system, do our BGP advertisements, et cetera. So we have been leveraging and hoping that there is some form of allowing us to bring our IP addresses to a cloud provider soon. I'm going to just bump over to Jeremy on that. We really want that. And that's a game changer for us, because if we can bring our IPs, then we can actually do things like go to the cloud, other than just be our back-end services where we still have this long string of network traffic that's going to go get data. We want it to go right into the cloud. And we can't go to 10,000 customers and say, hey, pretty please change those 2 IP addresses in your DNSA records. Come on over. That's a nightmare. Nobody wants to do that. And so being able to manage that public space within a cloud provider is critical for us, and it's something that we're hopefully looking forward to soon.
Yeah, so he's ribbing me a little bit. This is a feature that we get asked for a lot, and it's something that we've been working on. Obviously, the infrastructure at Google is very complex, and just being able to bring in foreign IP addresses into our system and leverage our connectivity to our peers is both incredibly compelling and also incredibly difficult. So I would say, again, watch this space. I think this is something that we have been working on. I hear every day a new use case for this functionality, so it's clear that there needs to be an answer. In a lot of cases, we've got customers like Bitly who have a single or a few very, very well-known IP addresses, and calling a maintenance or a flag day and saying, hey, we're going to change everything to a cloud IP address is probably a non-starter. We're also in a world where we're multi-cloud now, and I don't even know what that means for maintaining autonomy over your own IP addresses, but it's another thing that we need to think about. We've even had some surprising use cases, I think, where traditional enterprises might have supply chain or EDI connectivity to other partners, in some cases thousands of other partners, where those are, again, IP addresses, public IP addresses that are well known by their partners, and it's something that they can't put their business at risk on trying to change those IP addresses. And I can relate one more story. I had, at a company I used to work for, we had some manufacturing problems due to IP addresses. It turned out that there were some certificates built into the manufacturing process that required a specific host on a specific IP address that was in a colo provider that we no longer had a relationship with. So these are things that I think we all probably have an issue like this someplace, and if you look into your infrastructure, there's probably someone who knows about it, and through heroic intervention has kind of solved some problems. But these are things that, again, with all of this, we need to automate. We need to build networks based on intent, and we need to eliminate the need for heroic intervention to keep our businesses running.
I wonder if it's useful, something like this is useful for Vimeo as well.
We put everything behind a CDN, so for the most part, like, we're really lucky. Nobody has any need to pin our stuff. So first time in my career, I've just been able to say, like, CDN's problem. So while public addressing is important for people to be able to get to us, it's not a identity for us on the internet. We regularly spin up additional CDNs and move stuff around, and so it gives us a lot of flexibility. There are one or two things on our network where we have sustained TCP connections that require non-CDN paths, but we handle those through other means, and they're not IP address identity bound problems.
I'd add one thing here too. Does anyone in the crowd have that IP lock problem? Is that a common thing? I'm asking generally because we don't get exposure to a lot of people that are like that. So
About 10 folks.
Yeah, a good chunk. So more than I expected. Makes me feel a little better. But one thing I will say about this is, and I'm gonna bring this up. You may not like that I'm doing this, but AWS announced last week that they're doing BYOIP, right? And I freaked out about that a little bit because I was like, oh my God, that's the thing I want. But there's a certain advantage in GCP's environment to being globally aware right away. The fact that if we're able to bring an IP address in, or if we could move to a Google IP now, we get global availability of that IP address right away. It's out of the box, and it works with everything right now. AWS's does not. It's region locked. So it basically moves us from one colo to another colo and doesn't really give us much disaster recovery. It doesn't give us much hot capability to run multiple data centers or to run the same hot data all over the world to lower worldwide latency. So just some considerations to think about if you are in that IP lock scenario and you're looking for the little things that you may not be thinking about right now about what that means to move that IP address around, because it's nuts.
Yeah. Is it a roadmap item for Google? I'd say yes, it's a roadmap item for Google. Yes.
So the question was, is it a roadmap item for Google? Jeremy answered that. And then how subtle was I trying to be? Like 50 on a scale of 100. Subtleness is what my goal was there. I'm just saying that we got really far down the road in a lot of different places and realized at the last minute, this really is just a lateral move for us. It's not a feature add. And feature add is what moving to the cloud's all about, right? I can look at every database I have and every big data application I have and say, gosh, when I move to the cloud, things are going to be so much better. And the same kind of goes with IP addresses if you start looking around. But there's things to just think about in that. So global is better.
Global is better. So we're
if you got a question, come up to the mic.
Oh.
I can hear you. That's not the mic.
Yeah, so the question is multiple public IP addresses per VM instance. That's also a roadmap item. I'm working on it, so if you want to find me afterwards, we can talk about it. So we're going to run out of time, and I want to talk about IPv6. Yes, so before we completely run out of time, everyone that is currently running IPv6 on your network, raise your hand. Okay, so a quarter of the crowd. That's excellent. That's better than normal. It means we're making some progress. Of the folks in the crowd, how many plan to be running IPv6 on their network within the next year? Keep your hands up. 2 years? 3 years? Okay, so that's still a little bleak. I'm hearing we need to, and when we need to. I see. Yeah. So it turns out this is a very, very common problem with v6, and so I have 2 comments to make about it. First of all, we think that we've solved most of the problem for folks who need public v6 with our global load balancer support for v6. We do recognize that we need to bring that to the network load balancer as well. But that would cover off most of the public access to v6 addresses that we need. What I think is kind of shocking and interesting, and it really relates to this conversation that we've been having about internal IP addresses or private IP addresses, is that there are a vast number of enterprises who are just out of IP address space. They're out of RFC 1918 space. I see a hand. I see a couple hands. More hands.
Wow.
They're happening. And that happens for a lot of reasons, right? It happens because you have a lot of growth. It happens because you allocated IP addresses fairly liberally early on, and now you're dealing with a 10 or 20-year-old IP allocation policy. It also happens through acquisitions, right? And so to solve this, we get a lot of requests. We get requests to support non-RFC 1918 space addresses in our cloud. That is also something that we're working on that will be available. But the real answer to this is a move to v6. And a move to v6 is tough, right? And it requires for an enterprise to really embrace this. I've got a couple of customers that I talk to frequently who are out of 1918 space. They would like to move to v6, but they're one department in a group of many, many departments, and the other teams that they need to talk to would not be as eager to move to v6, or they might not be technology teams that can take that handoff. So we're hoping to lead it in the cloud, and what we plan to do is really focus on the enterprise use case or the internal use cases for v6. And so that's things like VM to VM communication, which you won't find on other clouds, talking v6 VM to VM, VM with internal load balancers, and also the ability to talk back to your premise over v6 via dedicated interconnect, partner interconnect, or over a VPN. So that's the stuff that we're working on. I see a hand. Yeah, so the question is, I love this question. You set me up perfectly. So the question is, are we willing to consider a v6 gateway or a 6-to-4 NAT that would enable you to run v6 in cloud and not worry about what other folks are running? And I think that's, from my perspective, that's the right approach. I would rather take an approach where, so Urs Holtze, our I want to call him our CTO because that's what he feels like to us, but he's the SVP of infrastructure. And the way he talks about this is the problem with v6 is that it basically introduced a new API without getting rid of the old API, right? And that's not how we do things, right? In every other part of development or operations management, you don't just let 2 APIs hang around at the same time. And so what I'd like to do, I don't know if we'll be successful, but with customer support, we could do this. What I'd like to do is to offer a v6 only option with these kinds of gateways so that when you switch, you only have to deal with one IP address family. You don't have to worry about both. You don't have to worry about securing v4 and v6. You don't have to worry about these label abstractions, et cetera, with v4 and v6. And if we just always do dual stack, you're always going to have a v4 problem, right? And if you've already got a v4 problem, just by simply adding v6, I'm just adding to it. I'm not actually solving it. So I hope that answers the question. Yeah, so the comment is that due to the ephemeral nature of most of these cloud assets, it might actually just make more sense to fully cut over. Yeah, yes. So there's a question about extra bits and what you could do with those bits. So interesting thing about v6, and another area where IP addresses weren't built for clouds. Most of you who have been running v6 are accustomed to using things like stateless address auto configuration, or SLAC. And that means that you're burning a /64. You have 64 bits that are basically reserved for the host to come up with, its unique identifier. This is completely unnecessary. That was built. It was actually a transition mechanism, and this because we have multiple APIs. In our cloud, we're not going to do SLAC. We're going to do DHCP. You're going to get IP addresses in that way, or you're going to statically assign them. And so the thinking on this is, okay, you don't need 64 bits, really. Come on, right? But we could still offer you some bits to play with. And so what if we gave you a /96 per host? If you had a /96 per host, you have 32 bits that you can manipulate to your heart's desire. That's 32 bits. That's the size of today's internet on every host, right? So you could use those bits completely on your own to encode whatever, process ID or service ID or anything like that, and still preserve the very lowest order bits for your host identifiers. So suddenly you get the same benefit of this tuple of an IP address and a tag, all within an IP address. And so this is an area that I think, this isn't probably something that the cloud is going to solve for you, but it would be good, I think, if we start thinking about, especially folks who are IPv6 practitioners, thinking about v6 for cloud, not v6 for internet service providers, or v6 for remote enterprises, or v6 for tunneling.
Jeremy, so perhaps we can ask quickly, how important is v6 for both of you?
I want v4 and v6 at the edge. What I run internally is not hugely important to me.
Yeah, our infrastructure is not big enough where v6 is a requirement, and we've yet to have one customer come to us and demand quad A records or anything like that. So for us, we provide 301s. Not a ton of benefit for HTTPS or for IPv6 in that aspect.
All right. Well, I want to first of all thank you all for showing up at 9 a.m. on the last day of the conference.